Hello. We're gonna go over my favorite, paper 2, the short answers, and then that'll probably be like an hour anyways, and then I'll do the long answers some other time. And so yeah, this is the last of the papers that I have for HL, because like I said, I only have access to time zone C, being that I was formerly a teacher in time zone C. And then there's the SL papers, I guess, which I'll go through when I have time. But okay. Let's see. Here's the first one. The first, like, 5 are SL, usually. Darren buys a car. It decreases by 15% in the first year. Find the value of the car at the end of the first year. So if it loses 15%, then that means that you've retained 85% of your value. I can't believe this is 2 marks. So we will just find 85% of 35,000. So that's 29,750. And then after the first year, the car value decreases by 11% instead each year. Find the value of Darren's car 10 years after he buys it, giving your answer to the nearest dollar. How is this an IB level question? Okay, so if it's 10 years, then that basically means that you have 9 years of 11% depreciation, right? So after the first year, this is how much you have, and then this is going to depreciate by 11%. So in other words, you retain 89% of your value, and that is for the next 9 years. So we'll just do this and multiply by 89% 9 times, and then you'll get your answer. So after 10 years, your car is like $10,000. 10,42310. Okay. And then let's see. When Darren has owned the car for n complete years, the value of the car is less than 10% of its original value. Find the least value of n. So n complete years are going to kind of do the same thing. We are going to use this equation, or well, this kind of format, and we're going to solve for n minus 1 technically. So we have 29750 0.89 n minus 1, and then we want to find out when it is equal to 10%, and then the first time that it's less than 10% would be the next whole value of n. So what was it? 35,000, right? So we're finding out when this is $3,500. That's 10%. And then we have to solve this. And then there's a lot of ways you can solve this. You can use logs. You can graph an exponential equation and find out when this is equal to here. You can use an equation solver. So it's up to you what you want to do. And this is why I don't like paper 2s. But I'm gonna use Wolfram Alpha and then pretend that this is your GDC's equation solver. So I'm gonna solve, what was it, 29750, and then it was 0.89 to the power of n minus 1, and then we want this equal to 3,500. So this is my equation solver, blah blah blah, give me 19.3, right? And then from there, we're gonna round this up to 20 years. Sure, that seems good enough. Okay, next up. We have a cone, 20 meters. Oliver is 5 meters from the base. His eye level is 1.8. Angle of elevation is 58. Find the radius of the cone. So we want to find the radius right here. This looks like we're going to do some right angle trigonometry. Oh, okay, yeah. So we are going to use a right angle trigonometry on this triangle right here. We're going to find this distance here because we know this is 58 degrees, and this height of the red triangle is 20 minus 1.8, which is like 18.2. So in other words, we have tan 58 degrees is 18.2 over d, so d is 18.2 divided by tan 58. And then the radius is just 5 meters subtracted from this distance. Okay, so I guess we'll calculate that. I guess the only tricky thing would be make sure that your calculator's in degree mode. Because, you know, we're talking about degrees. So 18.2 divided by 1058. Okay, so this is how far Steven or whatever is away from the center of the cone. And then we're gonna take off 5 meters. So your radius is 6.373. What did I say it was? 373? Sure. Okay, and then we need to find the volume of the monument. So we're just finding the volume of the cone. We have the height of the cone, we have the radius of the cone. So we follow the formula. I think it's like 1/3 pi r squared h. So we're just gonna plug in the values that we have. And this is pretty straightforward. It's only the second question. Okay, where the hell is tan? Where pi button? Here, right? Okay, divided by 3, and then 6.373 squared times 20. So 850, and then 641, right? 3 significant figures. And then I think this is meters cubed. Okay, easy peasy so far. Okay, random variable x is normally distributed with mean of 10, standard deviation of 2. Find the probability that x is more than 1.5 standard deviations above the mean. So we want to find out that the probability that x is greater than 1.5 standard deviations. So standard deviation, they said, is 2. So 1.5 of 2 is 3. So we're finding out when x is greater than 3. And because we have the mean and the standard deviation, this is just a normal distribution. So we can go into our distributions and go to normal CDF. And then we have a lower boundary of 3. We do not have an upper boundary, so just pick, you know, something large, like 10 to the power of 99. And then what did they say? Mean was 10, standard deviation was 2, and then there you go. That's a very big probability. Maybe I typed in something wrong. Or maybe I didn't even put this into the calculator properly. It's been a while. Is more than 1.5 standard deviations above the mean. Yeah, 1.5 of 2 is 3, right? Am I going crazy here? This like rounds up to 1, doesn't it? So it's like guaranteed? That seems weird. Whatever. I'll think about that while I work on the next one. The probability that x is more than k standard deviations above the mean is 0.1, where k is some real number. Find the value of k. So the probability that x is more than some number, so it's not k, because k is how many standard deviations that you are above the mean. Oh, it's above the mean, that's why. So then I should put 13. Because it's 1.5 standard deviations, which is 3 above the mean, so it's 3 plus 10. So let me go back to this thing. And then let's put in 13. Tricky. There you go. That looks good. So 668. I mean, I guess you could just normalize this too, because it does talk about, it's like centered. Yeah, if you wanted to, then this is the same probability as this, where you have your mean is 0 and your standard deviation is 1. You would get the same thing. So actually that's easier. So let's do that. So part B, we're finding essentially the z-score. Call that little z. This is big Z. So now we want to find this boundary. So this is an inverse normal. And we know that the area is, and then for TI-84 plus Silver Edition, it only does a left tail. So if this is actually a right tail, because this is 0.1 on the right side of this boundary, because Z is greater than this boundary. So for this, I would put 0.9. A lot of newer models, of course, let you choose which tail your area is. But we got 1.28. So 1.28 standard deviations. Yeah. So this was a little tricky because you had to realize, I guess, that because they are counting in standard deviations, like how many standard deviations is it, it's better to normalize your distribution, because normalized distributions are essentially measuring how many standard deviations you are away from where the mean is. Tricky. I think that might trip up a couple of SLs that don't really understand like normalizing your distribution. Oh well. Okay, a particle moves in a straight line. This looks like kinematics. So from 0 to 10, this is the velocity. So Let me just highlight that. Velocity graph. Then we need to find the smallest value of t that the particle changes direction. So to change direction means that you are finding out when velocity is 0, and then you're gonna do a couple of other checks. To change direction means that you need to be moving like one way, and then you stop, which is why your velocity is 0, and then your velocity, like you go the other way, you change direction. So we're looking for places where one side is positive and then the other side of the 0, so this is where you stop, right? Where this is negative, or vice versa, like here, right? You're moving to the right because you're positive, and then you move to the left after you stop because you're negative. Luckily, you know, they didn't have the graph go like this, because this means that you would not change direction here. It basically means like you're moving forward and then you stop here and then you keep moving forward. So you did not change direction. But anyways, easy peasy. We're gonna find out what these intercepts are. I'm pretty sure they tell you the function, so we can graph this and then whatever. The only tricky thing again is that this is in radians. So if you had done this question properly, your calculator is probably in degree mode. So then you would need to switch it back into radians before you put this in. But I'm gonna use Desmos instead because it's technically faster than me using a GDC. So I'm just typing this off screen and then I'll bring it over. So okay, so here's the graph, right? So here are my two places where I change direction. 1.687 and then 6119. I will not be able to remember those. 6187, 1687, and then this is like 119, I think. Six 187, 6119. Okay, there you go. Next, find the displacement is measured in meters from O, sure. Find the range of values of t for which the displacement of the particle is increasing. So this is just understanding the relationship between, let's say, displacement and velocity. Velocity is the derivative of displacement. Actually, they don't usually use d, right? They use like s or something. So let's call s displacement. Then velocity is the rate of change of displacement, which is the derivative. And then to find out where displacement is increasing, that just means that the gradient is positive. So this just means d dt is positive. In other words, we just need to find out where your velocity is positive on this graph. And that's pretty easy to see. It's your velocity is positive here. So there is your range of values from here to there. Then we find the displacement of the particle relative to O when t is 10. So this we just integrate from 0 to 10 of your velocity function. And you can do this in your calculator. There's a definite integral button in the GDC. There's no point in me doing it here because you guys will all have different models. But I'm pretty sure I can go here. And then let me call that like f of x, let's say. And Desmos, I'm pretty sure, has integral abilities. But so there is your displacement. It's negative. That just means like from wherever O is, you're like to the left of it, or however you want to orient your space. Like up is positive, down is negative, or if it's moving left and right. So negative 2.13 like meters. Okay, and then this looks like linear regression. You have a class that's given 2 tests, A and B. These are the different students. And then you have X be the score of test A and B. Okay, they do a regression of Y on X. And then we need to find Pearson's correlation coefficient. So you need to turn it on. There's like a stat thing you need to turn on. Stat diagnostics, at least for TI-84. So I'm just checking that that's on. Okay, and then we can put this on into the table. Let me just clear out the old data from the last time I used this calculator. And then test A is X. And we're going to regress test B on test A then. So let me put in test A numbers. Oops. So 100, 93, 81, 80, 88, 100. Why did they give you so many? 61. Okay. And then we got 58, 80, 92, 98, 90, 82, 100, 100, 65, 74. Okay, and then once that's in, we can go back to stats and then we can calculate a linear regression. And then my X is test A, which is list 1. My Y is list 2. We can calculate. And then your Pearson's correlation coefficient is there, 858. Which means that is decently strong of an increasing thing. So if you were to graph these, so your score on test A and your score on test B, it's like kind of linearly positively correlated like that. Okay, let's see. Giovanni was absent for test A. Paulo is absent for test B. The teacher uses the regression line to estimate the missing scores. Oh man, that would get you in trouble. Paulo scored 10 on test A. Paulo's the one that is missing test B. Okay. The teacher estimated his score on test B to be 27 using the regression. Okay. That sounds kind of dumb. Give a reason why this method is not appropriate for Paulo. It's only worth 1 mark, but like basically there's like this trend in the test, in the relationship between the 2 tests, right? And then Paulo has a score in test A, which is like 10. And this teacher is using the regression line to predict his test score for test B, which isn't like, there's a lot of things that you could say why this is not correct. Like, in terms of common sense. One, test Paulo's knowledge in test A may not be correlated to how well he knows his knowledge in test B. They could be like one test could be about math, one test could be about socials, right? Like this is a correlation. It's not like a causation. So generally when they ask you these types of questions, like they're looking for something like that. Like this is just correlation, it's not causation. Just because he has a low thing on A does not mean he's gonna have a low thing on B or vice versa. Okay, Giovanni scored 90 on test B, so then he needs to calculate his test A mark. So I think he assumes that this is the Y value, and then he solves for X, and then give a reason why this method is not appropriate for Giovanni. Any of the same reasons, I think you could say, right? The main thing is also you should not use a regression of X on Y to find X. And then that's what I think this is, right? Using a more appropriate method, what you should do is you should find the regression of X on Y, and then we would more or less plug it in like this. We would have an equation that looks like X equals something like this. And to be honest, I never really learned stats, but I think that this regression is not the same as solving for X. So it's better to just reverse your regression and then plug in Y in here. So we can do that real easy. You just basically recalculate the linear regression, but you switch the lists. So this one we're gonna call list 2. And then this one we're gonna call list 1. So it's 937. And then minus 005. Okay, and then let's plug in his 90 in here and see if we get 86 to the nearest integer. I did not get 86. I got 84. Did I just say all of this, and it's completely wrong? I don't think this will make much of a difference, but I did round this incorrectly. It's okay. Let me just double check this one more time. No, I still don't get 86. Well, shoot. Yeah. Someone can tell me where I went wrong in the comments. Statistics is not one of my stronger suits. I never took a statistics class. Oh well. Maybe I'll think about it more and then I'll make a comment or something. Number 6. In Happy Land, weather is independent. The probability of rain is 0.2, May is 31 days. Find the probability that it rains exactly 10 days in May. So this is a binomial distribution. you have 31 independent days, and then each one has the same probability of rain. So we are just gonna use our distribution, Binomial PDF. So 31 days, the probability of rain is 20%, and then we are interested in having exactly 10 days of rain. So like 419? About 4% chance. To find the probability that it rains at least 10 days in May. So this is a cumulative now. And my TI-84 cannot do a lower boundary question for cumulative binomial. So what we're going to do is we're going to write this as the complement of at least 10 days. So 10 or more is the same as less than 10. And because these are about days, less than 10 is the same as less than or equal to 9. And then this we can just put into the calculator. So 1 minus binomial CDF, 31 days, 20% chance of rain, and then 9. Okay, and then this is 745, 746. Okay, and then for part C, find the probability that the first day it rains in May is on the 10th day. It's only worth 2 marks, so I think you just need to the first 9 days are no rain, and then the 10th day is rain. So we just multiply this out. I don't think it's any deeper than this. So 2, 6, 8. I may or may not be missing a 0 here. I forgot what it said. Oh, there is a 0. That linear regression question's bugging me. Oh no, this looks like a differential. Solve this differential. Give your answer in this form. Okay, so for HLs, you guys learn like 2 or 3 techniques. They're separable equations, which this is not. There's no way to like separate y and x with the dy and the dx on separate sides. And this isn't just like something you could take by inspection and looking at it. However, you do have some function of x and then separately some function of y. So I think this one is the integrating factor. It is in your formula booklet, but I forget exactly how much in detail it talks about it. So let me get that formula booklet. IB Math formula booklet. Yeah, so you see this is the format of our question. This is x. Like if we just subtract the y to the other side, then it has this format. So let me just copy paste this. So I'm gonna just rewrite it as y prime. It's a minus y equals x. So we can see here that p of x is just -1 and q of x is just x. So what that means is that your integrating factor is e to the power of the integral of -1 dx. And if we integrate that, that's just e to the negative x, I think. And what we do is we multiply everything in our equation by the integrating factor. So this results in y prime times e to the negative x minus y times e to the negative x equals x times e to the negative x. And this whole process is designed so that if you multiply by this integrating factor, on the left side, this is more or less a product rule. I know I'm mixing my notation here, but this is essentially the result of a product rule, and we're taking the derivative of y and e to the negative x. So if we take the derivative of this is what we should get, right? Derivative of y times e to the x, and then y times the derivative of e to the negative x, so then that's a minus e to the negative x. And then once we're here, then we can just integrate both sides. And then on the left side, by fundamental theorem of calculus, we have this. And then on the right side, I think you need to do an integration by parts. So we're gonna say u is x. So du is dx. dv is e to the negative x, which means that v is negative e to the negative x. And just let me double check this. Sure, looks good. Okay, so then the right side by integration by parts is negative x e to the negative x minus the integral of negative e to the negative x dx. Okay. And then if we take the integral of this is just e to the negative x. And then I think there's a plus c here. Right? Integral of this is just this. And then we want y. So I'm gonna basically multiply everything by e to the positive x so that these cancel. And then I think that's kind of nice because it'll cancel out with all of these too, right? So we get y is equal to negative x minus 1 plus c e to the x. And then I'm pretty sure they told us values for y and x, 2 and 0, so then we can find out what the constant is. So now I know this is 2 equals minus 1 plus c e to the x. So c is 3 over e to the x. Oh wait, no, hold on. I forgot to... There you go. C is 3. Right, x is 0, so then this is just going to be c. Which means my function is negative x minus 1 plus 3 e to the x. Sure, looks good. Continuous random variable. So here we go. Show that this equation satisfies the thing. So the property of continuous random variables is that if we take the integral of the function from the limits or boundaries of the function, in this case it goes from 0 to 2k, then this should be a sum of 1, because it's the total probability, which is 1. So from there, yeah, we can just take the integral in 2 parts and then plug in the limits and probably manipulate it, and it'll turn into this. So we have from 0 to k, you got kx. And then you got from k to 2k of this one. Okay, so this integral is k over 2x squared, and then this integral here is going to be kx squared minus x cubed over 3, I think. And then we're going to plug in our limits using fundamental theorem of calculus. So then we'll have k to the power of 3 over 2, and then if you plug in 0, you'll just get minus 0. On the other side, we plug in 2k first, so this is going to become 4 k to the power of 3 minus, I think, 8 over 3 k to the power of 3, and then minus, we're going to plug in the lower limit for the second integral. This is k to the power of 3 minus k to the power of 3 over 3, and we said that this is equal to 1. Ew. Okay. Well, let's see. Let's multiply everything by 6. So then this becomes 3k. This is 24. This is going to become 16. This is 6. And then this is 2. And then that's 6. So just multiply by 6 because we have denominators of 2 and 3. And then, okay, let me write this out. We got 3k cubed plus 24k cubed minus 16k cubed minus 6k cubed plus 2k cubed. And this should equal to 6. And what did I need to show? Okay, the left side is probably going to become 7k cubed. I'm not gonna check it. I don't care. This is probably how it happens. Done. And then this means that k is the cube root of 6/7. And then we need to find the median. Damn, this is only two marks? Was there a faster way to do this? Oh well. Okay, find the median of x. So the median is from the beginning of your function limits, so in this case 0, to some number, which we're trying to find out, m. This is your median. So this is where your probability is 0.5. Okay, so what you should check first is m could either belong in the first part of the function, or it could belong in the second part of the function. So what we're going to do is, because we know what k is, you can do a quick check on the first integral. So from 0 to cube root of 6/7. So this is the first part of your function. You're gonna see if this is more than 0.5 or less than 0.5. Because if you know that this is more than 0.5, then that means that your median lies in the first integral. So, or rather, your median lies in this first interval. And then if this is less than 0.5, then that means that your median occurs in the second part, in this interval. Okay, so this you can just do a definite integral. Which is somewhere here, like right here. So this goes from 0 to cube root of 6/7. So I'm just gonna write it as to the power 1/3. And then your integral is cube root of 6/7 x dx. Okay. So this is 0.429. So in other words, like your function what we found out is this area, and we know that it's 0.429, so our median is somewhere here. In other words, what we're trying to now solve is we're trying to solve from m to 2k, 2kx minus x squared, I think it was. We're trying to solve this equation. We now know that this is 0.5. Okay, so from there, I already know what this integral is. I did it here. Not that it's a hard integral to do again. Okay, and then we know that if we plug in the limits, you would get this thing. This is kind of gross, but I guess we'll just do it. We'll do it again, plug in our limits. What did I get? It was like 4k cubed minus 8/3k cubed minus km squared minus m cubed over 3. This is 0.5. Yeah, so I just plugged in these and I'm keeping it as k. I know what the value of k is, but yeah, and then we just solve this, right? Solve for m. So this is an equation solver question. Oh my god, okay. I could simplify it before I type it in. I guess I should do that. So this is 4, 6 over 7, and then 8 over 3, 6 over 7, minus, yeah, but this one's ugly. Okay, equation solver. So what was it? 4, 6 over 7 minus 8 over 3, 6 over 7 minus 6 over 7 to the cube root, and then it was m squared. I'll just use x minus x cubed over 3, and then this is equal to 0.5. Okay, approximate forms, please. Okay, and then we have 3 solutions here. It's not the negative one, obviously, and then it's one of these two. I have a feeling that this one is too big. This is outside of our limits. This is probably more than 2 times k, which is our upper limit. So let's just take the middle one. So 1.03 is the median. Am I done yet? How much more is there? Is there 10? Okay, this is the last one. Oh my god, 9 short answer. Oh no, this looks like combinatorics. Okay, remember how I said I'm bad at stats? That also includes combinatorics. I think combinatorics is like, I'm so bad at combinatorics. So if there's one that I'm gonna completely get wrong, it's this one. So if I do, be nice and let me know how it's supposed to be done. We have a group of 10 children, which includes 2 brothers, A and B, Alvin, Bobby, and then 2 sisters, C and D. Children, 10 desks, 2 rows of 5. Alvin and Bobby gotta sit next to each other in the same row. Find the number of ways the children can be seated. Okay, I'm gonna see. We're gonna break this down step by step. So first off, they need to sit in one of these rows, right? There's 2 rows. So you gotta select a row first. So there's 2 ways for that to happen. And then when you have people sitting together, you treat them like one unit. So A and B, we can consider as one person. So what you're gonna do is you're gonna arrange those 4 people in the row like this. And then you multiply that by 2 because like Bobby and Andy or whatever his name is can sit, you know, left or right of each other. And then you need to sit the rest of the people. Who sits with... Oh, and then you need to pick who are the people that sit in that row with Andy and Bobby. So in that case, there's 8C3, right? And then from there, you need to sit the other 5 people in the other row. So this gets multiplied by this. Right? Essentially, each multiplication is a choice that has to be made. So 2 rows, arrange the 4 seats, multiply by 2 for switching A and B. You also need to select the 3 people that are sitting with them, and then the other 5 sit in the other row. Okay, let's say that it's this. So 2 times 4 factorial times 2 times 5 factorial times 8C3 so 645120. Okay. And then after an argument, C and D cannot sit next to each other. A and B must sit next to each other. Okay, so if people cannot sit next to each other, you need to find out the ways that they do sit next to each other, and then basically subtract them from all of the ways that they sit. So because A and B must sit next to each other, then this is all the ways that A and B can sit next to each other. So then we need to find all the ways that C and D can sit next to each other while A and B sit next to each other, and then we subtract the 2. Okay. Oh my god, let's see how this works. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, if it's like the first one, then we're gonna do a similar breakdown, except there's 2 situations. There's A, B, C, D in the same row, and then A, B, and then C, D are in different rows. Okay, if A, B, and C, D are together in a row, then first there's 2 options for which row they sit in. And then A and B can switch places, so that's times 2. C and D can switch places, that's times 2. And then this is technically 4 people, so there's 1 more person that can sit here, or will sit with them. So there's like 6, right? 6 choices. This is the extra person that sits with them. It's just 6C1, but 6C1 is the same as 6. Okay, so we selected all the people and arranged all the couples, but we need to arrange how they sit together. So this is 3 factorial. So we can treat these guys as 1 person each. So then that's 1, 2, 3 seats. And then from here, you sit the rest of the people in the back row or the front row. Okay, so I think that's if they sit together, and then let's find out if they do a different row. So there's two ways to sit A and B. So the moment A and B get selected, then C and D have to be in the other one. So we just do a times 2. So we sit A and B first. And then there's two ways for A and B to sit beside each other. C and D do not sit in the same row, so from the other 6 people, 3 of them will sit with A and B in the front or back row. And then this is 4 factorial. So now we arrange them in the 4 seats in the front or the back. So that's very similar to this. Except it's not 5 factorial because the other row now has to see C and D. So C and D have 2 ways to sit next to each other. The rest of the people sit there, so then and then there's like a 4 factorial, right? Okay, so this is front row. This is back row. This is all the ways that C and D can sit with the other 3 people. I think. I feel like there might be another thing here for arranging the other people, but that might be as this. Okay, let's just go with that. And again, just let me know if I'm wrong. So then we add these together. And then this should be the total ways that A, B, and C, D sit together. And then we subtract that from all the ways A, B can sit together. And then that should leave us with all the ways that A, B sit together, but not C and D. Okay, let's put this onto the calculator then. Okay, 2 times 2 times 2 is 8 times 6 times 3 factorial 6 times 5 factorial, which I should probably know off the top of my head, but whatever. Alright, this is going to be added to 2 times 2 is 4 times 6c3 times 4 factorial. 4 factorial is 12, I want to say. 4 times 3 is 12. Oh, times 2, so 24. Okay, times 2 times another 4 factorial, so times whatever. I'll just type it in like this. Okay, 126720. And then we subtract the 2. So 5184 is 100. Let me just add some annotation, I guess, for you guys. So this is AB, and then this is AB and CD. So this is AB with no CD. Sure. Again, I feel like this might be wrong, but overall, this is kind of the strategy. And then we're done. Okay. Yeah, it's okay. It's not bad so far. Except for this linear regression one. That's still bugging me. But I don't know. I'll take the 4 marks off. It's fine. Just give me 0 on that question. I'm pretty sure I got most of these right anyways. Maybe not this one. But yeah. Okay. I'll go through the long answer questions another time. And then I guess I'll do the SL ones. And then the SL ones should be shorter because I'm gonna skip all of these questions that would have been in the SL exams. Unless they might have like slightly different parts at the end. Like I remember in paper 1, this one here. This is a very SL level question. I'm gonna expect this on their paper, and maybe they don't have a question F because this is a strictly HL topic about the product of roots. Okay. Thank you for listening, and if you did, please let me know how to do that linear regression problem. Otherwise, yeah, see you guys later.